It is my pleasure to introduce Cadet Matthew Walkus of the S2 staff, who will introduce our keynote speaker.
Good morning. I'm Cadet Matthew Walkus from the S2 staff. It is my pleasure this morning to introduce our keynote speaker, Dr. Neil deGrasse Tyson. Dr. Neil deGrasse Tyson was born and raised in New York City, where he was educated in public schools until his graduation from the Bronx High School of Science. He went on to earn his Bachelor's of Arts in Physics from Harvard and his PhD in Astrophysics from Columbia. Tyson's professional research interests are broad, but include star formation, exploding stars, dwarf galaxies, and the structure of our Milky Way. In 2001, Tyson was appointed by President Bush to serve on a 12-member commission that studied the future of the U.S. aerospace industry. The final report was published in 2002 and contained recommendations for Congress and major agency of the government that would promote a thriving future of transportation, space exploration, and national security. In 2004, Tyson was once again appointed by President Bush to serve on a 9-member commission on the implementation of the United States space exploration policy, dubbed the Moon, Mars, and Beyond Commission. This group navigated a path by which the new space vision can become a successful part of the American agenda. And in 2006, the head of NASA appointed Tyson to serve on its prestigious advisory council, which will help guide NASA through its perennial need to fit its ambitious vision into its restricted budget. In addition to dozens of professional publications, Dr. Tyson has written and continues to write for the public. From 1995 to 2005, Tyson was a monthly essayist for Natural History magazine under the title Universe. And among Tyson's 10 books is his memoir, The Sky is Not the Limit, Adventures of an Urban Astrophysicist, and Origins, 14 Billion Years of Cosmic Evolution, co-written with Donald Goldsmith. Origins is the companion book to the PBS Nova 4-part miniseries Origins, in which Tyson served as on-camera host. The program premiered on September 28th and 29th, 2004. Two of Tyson's recent books are Death by Black Hole and Other Cosmic Quandaries, which was a New York Times bestseller, and The Pluto Files, The Rise and Fall of America's Favorite Planet, chronicling his experience at the center of the controversy over Pluto's planetary status. The PBS Nova documentary, The Pluto Files, based on the book, premiered in March 2010. For 5 seasons, beginning in the fall of 2006, Tyson appeared as the on-camera host of PBS Nova's spin-off program, Nova Science Now, which is an accessible look at the frontier of all the science that shapes the understanding of our planet in the universe. During the summer of 2009, Tyson identified a stable of professional stand-up comedians to assist his effort in bringing science to commercial radio with the NSF-funded pilot program, Star Talk. Now also a podcast, Star Talk Radio combines celebrity guests with informative yet playful banter. The target audience is all those people who never thought they would or could like science. Tyson is the recipient of 14 honorary doctorates and the NASA Distinguished Public Service Medal, the highest award given by NASA to a non-government citizen. His contributions to the public appreciation of the cosmos have been recognized by the International Astronomical Union in their official naming of asteroid 13123 Tyson. In February 2012, Tyson released his 10th book, which is devoted to space exploration. Space Chronicles, Facing the Ultimate Frontier. And he is currently working on a 21st century reboot of Carl Sagan's landmark television series, Cosmos, to air in 13 episodes on the Fox network in 2013. Tyson is the first occupant of the Frederick B. Rose Directorship of the Hayden Planetarium. Please join me in welcoming Dr. Neil deGrasse Tyson.
Thanks for that warm introduction. Do I have time left for the talk? I guess my slides will show up in the upper corners. If there's stuff on it you can't read, it doesn't matter. Because the messages are mostly coming from my mouth. But I try to find a title for this talk. I call it Adventures in Science Literacy. But in fact, the talk should be titled Adventures in Science Illiteracy, because I will be bringing to you examples of what I've seen in my walks through life that drive home why I think science literacy is not just important for STEM literacy in general. It's not just important for the training of the mind, it's important for all manner of subjects that include national security, includes economic competitiveness. So it's not just for personal intellectual enlightenment, it goes much deeper than that. You know, often talks such as this are like loosely veiled commercials that people give to market their books. And so this was no exception to that. No, actually, oh yeah, so right, there's the space book. Actually, nothing I'm about to tell you in this talk appears in any book. I don't like giving book talks because you could just read the book. If you have me in person, I might as well tell you something you can't otherwise get. So I just want to review just what happens when you care about STEM fields. Just sort of the consequences when a nation, a state, a community, a culture, when they care. And I'm going to take these examples from chemistry. So you all remember this, right? Some of you wanted to forget it. The periodic table of elements, color-coded. I have some software that allows you to color code different features of the table for instant reference to what's going on there. So for example, here's color-coded for melting point. So the redder you are on this table, the higher is your melting point. And notice there's a bunch of elements right there in the middle. There's like tungsten and osmium and iridium. These have very high melting points. And so had Edison had access to this software, he would have known immediately that tungsten would be the material of choice for his light bulb. With a very high melting point, you're sending current through it, you don't want it to melt, or you don't want it to melt immediately. And so, as a result, he was trial and error, essentially, just experimenting with different materials, different metals. So there's one way you can color code it. Another one is by discovery date. So the elements in blue are those elements known to the ancients. Everything in gray was unknown to them. So they knew maybe 8 elements or so. Sulfur is in there, carbon, copper, gold, silver, that sort of thing. And you can slide the time bar forward, and now we're up to, what time is it? 1776. So these are the elements known at the Declaration of Independence. So there's an extra 6 or 7 elements there. Still, you don't have the full-fleshed periodic table. Now we're up to, what year is that? 1869. So now we've got the semblance of a periodic table going there. These elements are discovered by different countries around the world. In fact, let's find out who made these discoveries. Let's just do that, okay? So what we're going to do now is put the flag of the country responsible for the discovery of that element. Very revealing. Take a look at the bottom of that chart. From element number 93 on. It's this flag. That's the flag. I'm just saying, that doesn't happen by accident. This was not people in America just walking down the street and stumbling on an element, saying, look, I found an element. These are investments in particle physics, in particle accelerators, in an education system that values science literacy. So we discovered those, we got to propose the names for them. In that row, there's Californium, there's Berkeleyum. These are locations where these elements were discovered, the particle accelerators in that state. We've got, what else have we got there? Oh, there's also Neptunium and Plutonium, named after a planet and a dwarf planet. Plutonium was named at a time everyone thought it was a planet, so it ended up on the periodic table on false pretense, I think. But let me tell you something else. Look at the right-hand column there. You see the British flag, the Union Jack. England is like #1 in total elements discovered. Most of those were discovered in the 1800s and early 1900s. England ruled the world in the 1800s. If you look at the countries, so you have United Kingdom, Sweden, that's an exception, I can mention that in a moment. Germany, France, United States, Russia. These are countries that cared about, in their days, in their times and places, cared about discovery. But there's an interesting consequence to this. Do you remember what we call the elements on the right-hand side of the periodic table? The noble gases. You ever wonder why they're called noble gases? Okay, well, first, you may remember they don't really chemically combine with anything else. They have complete outer electron shells. And because these elements were discovered in England, they analogize these elements to the noble class, not hanging out with anybody else. So the class system of England is embedded in the naming of things on this table. And I'm reminded why we fought a war to get away from England 240 years ago. So you get to name stuff. There's also a little bit of pride. Pride I've yet to really see in America. Before the euro currency was introduced, all the countries of Europe would put their favorite people on their currency. Their people. It could be statesmen, authors. I happen to have a collection of these where the countries put scientists on it. So let's take a look. So the upper right, that's Nikola Tesla. That's Yugoslavian currency. Tesla was very important in the history of electricity. Poland has got Copernicus. We've got Italy in the bottom right. That's, who's that? That's Marconi, all right, who pioneered radio communication. We've got Volta on the bottom left. So Italy was big in electricity. We have units of measure named after people from Italy. The volt is named after that guy on the bottom left. So things get named after you. Your country gets remembered. You get honored on currency. This is the flip side, where it has iconography of their trade. The flip side of each of those. It doesn't stop there. I've got Romania in the upper left. A total solar eclipse went across their country. And they thought that was so cool, they put it on their currency. An eclipse. Can you imagine that happening in America? An eclipse happening, let's put it on our money? So other places are getting excited about their science. That's, of course, Charles Darwin on the bottom right. By the way, the designer of that currency made a mistake because Darwin studied finches, not hummingbirds. That's a hummingbird there. That's just a mistake. That was a non-biologically literate artist who was engaged in that. By the way, it's not just Europe. We can go to the Middle East. This is a currency from Iraq. That's Ibn al-Haytham, who pioneered sight. He was the first to recognize that light has to come into the eye to make an image. And he had pioneering discoveries regarding lenses. There's Einstein on an Israeli currency. Of course, Einstein is not Israeli, but he was really smart and famous, so people tend to want to claim you as their own when that happens. But that's fine, he's nonetheless a scientist. Keep going here. We've got Euler in the upper left, Galileo in the upper right, my man Isaac Newton, middle left. We've got Pasteur, bottom left, Faraday, Gauss in the middle right, German 10 Deutschmarks. Gauss. Wait a minute, I'm looking at that Deutschmarks there. Let's take a closer look. There he goes. He was an unimpeachably smart guy, Carl Friedrich Gauss. And look carefully on this money. Wait a minute. There's something you don't see often on currency. There's a mathematical distribution function on the money. Pi appears in a square root in this. Yeah. Now, wait a minute. If we were to sort of, over the past century, if you had to pick where you would expect to find a high concentration of excellent engineers, what country always rises to the top of that list? Germany, of course. It's even a selling point. German engineering. You hear that all the time. You don't hear Polish engineering, buy the product, right? You don't hear, maybe you could, you just don't, okay? You just don't. It is so understood and recognized, and I always wondered, maybe there's some correspondence there. In Germany, they have math on their currency. If you're a kid and you look at that, you wouldn't understand it when you first saw it. You might be curious about it. It might trigger later interest in what you end up studying. Actually, we have a scientist on our money. Who is it? Ben Franklin. 6 of you have seen a $100 bill. There we go. The rest of you, eventually, maybe you'll run into one of these. So I'm thinking, Ben Franklin was one of the most famous scientists in the world in his day. His book, Experimental Researches into Electricity, was like a best-selling science book in its day. So I'm thinking, where's the iconography related to his science? I don't see it. Is there a kite? A key? One of the things? No. So clearly he's not on the money for having been a scientist. He's there for having been a founding father. So what it means is entire generations of Americans don't think of him as a scientist because they don't have daily access to that information about him. We think of him primarily as a founding father, a lost opportunity. And out there, I see some bad mathematics. I'm sorry, I gotta get this off my chest. I'm born and raised in New York City. There's a lot of tall buildings in New York. And 80% of the buildings, I did this experiment, 80% of the buildings, if you walk into the elevator bank and look at they look something like this. 7, 8, 9, 10, 11, 12, 14. This is 21st century America, and we have people afraid of the number 13. And what happens when you get to the lobby and the floor's below the ground level? What do they call them typically? Yeah, base B, SB, SS, all these like letter combinations. Can I buy a vowel or something? What are you describing down here? And by the way, we have a perfectly good mathematical system for representing floors below ground level. What do we call it? Negative numbers, thank you. And you know who's not afraid of negative numbers? Germany is not afraid of negative numbers. Here is a history museum, not a science technology center, history museum in Germany. You go below ground level, there's 4 minus 1. You can't see that? Here it is, a little bigger. Minus 1. Germany, they're not afraid of numbers. Certainly not afraid of negative numbers. Let's come back stateside. What are we contending with? I got one for you. You ready? Ripped from a headline. Oh, you can't read it. I'll read it to you. Half the schools in the district are below average. A headline complains. You know, that's kind of what an average is, isn't it? You expect about half below, and that's how you get an average. Well, what did they expect? All the schools are above average? It doesn't work that way. They probably meant half the schools are below standards or below grade level. But this was a mathematically illiterate journalist. I got another one of these. I can't read it. I'll read it to you. This is a little more subtle. 80% of airplane crash survivors studied the locations of the exit doors on takeoff. Okay, so you read that and you say, that's a good number, 80%. I want to be in that 80%. So next time I'm on an airplane, I'm going to read where the exit doors are. But here's the problem. Just suppose 100% of the dead people studied where the exit doors are on takeoff. You would never know because they're dead. Dead people don't respond to surveys. So, for all you know, studying where the exit doors are makes you less likely to survive. Every state has a lottery, and often it's written that the state lottery is a tax on the poor because people with less money spend a higher percent of their disposable income, if there's any at all, on the lottery. So they say it's been a tax on the poor. You know, it's not a tax on the poor. You know, because if you're math literate, you understand statistics, you understand probability, you understand accounting. That's a tax on people who never did well in mathematics. That's what the state lottery actually is. And this one is my favorite. It's spoken in Congress. I've changed my views 360 degrees on that issue. You know, last I checked, 360 degrees, you have the same damn point that you had before. So what's actually scary is, suppose the politician actually understood what he was saying and wanted to fool everyone else into thinking he had changed his mind, but didn't. So I'm still wondering, is that better or worse than simply not knowing what 360 degrees is? I don't know, but that's what's going on. There's also some bad physics out there. Here's an ad. But I'm in Virginia. Are there any Bayer plants here in Virginia? Bayer, the pharmaceutical company? Good, okay. So, here's an ad they took out. I have to read it to you. So Bayer is boasting, letting you know that their engineers and lab people go into the schools and offer sort of hands-on, real-life experience for the kids. And so they're telling you about this program in the ad. And it says, you're on. Try to get them interested in why lighter things fall faster than heavier things. Come on, it's your turn. Now, first of all, their measure of the problem children, it's a black kid and a girl there, all right? Well, how about the white kid with the tattoos that came off the motorcycle? Where's he, okay? So they're first saying that these are the problem cases, all right? So I have a little issue with that, but that's not my biggest issue with this ad. Try to get them interested in why light things fall faster than heavy. There is no universe in which that's true. Light things don't fall faster than heavy things. This was a scientifically illiterate ad designer, text preparer. Down the chain, someone had to think of this ad, write the text, typeset it, compose it, design it, print it. No one caught this error. I mean, they eventually caught it and they changed it. So what they really mean is, try to get them interested, they fixed it here. Try to get them interested in why light things fall as fast as heavy things. Well, that's true. We learned that in Physics 101. That's the Galileo Experiment. I can do that experiment for you. So here's my shoe. I happen to have some chapstick here. Need soft, supple lips in this world, yes? So I think I don't have to show you that the shoe weighs more than the chapstick. You can just trust me on this one, okay? So I let them go together. They fell at the same rate, okay? Well, you're applauding Isaac Newton and gravity, not me here, when you do that. So that's the point they were trying to make. But what it tells me is that the people who belong in this science literacy program are the people who designed the ads and not the kids who are portrayed in it. Here's a weird one. This requires some explaining. This is an ad for Holiday Inn in the UK. And they had a new program where, you ever been into a hotel and you get in the bed, a long day, and the sheets are really cold, right? And so they figured that's not good. So you can, in advance, hire human bed warmers to pre-warm your bed. So these are the people on the left and on the right of the man in the middle. Now, of course, he's looking at her, not him. I don't know who he's looking at, but it's just weird. Now, holding aside the weird part, the bed warmers, are completely covered, because you have to keep it sanitary. They're completely cozily covered. Their head, their hands, their arms, in insulating robes. If they're wearing insulating robes, they can't make the bed warm. That's the whole point of insulating clothing, so your heat doesn't get out. So this person had a whole ad campaign, didn't understand the physics. Let me tell you how bad it is. Here's a map of the world, portraying each country in proportion to the land area that it occupies on the globe. So it's a regular map of the world. Okay, so what I'm going to do now is distort the area of each country in proportion to how much science gets published, how much research papers, peer-reviewed research papers, how many are published in each country. So if you're above the average, your country borders will grow. If you're below the average, your country borders will shrink. And so at a glance, you get to see where all the good science in the world is being done. So let's take a look at that. Whoa. So America's sitting fat and happy there. So what are we complaining about? Why are we saying there's a STEM problem? Look at that. Wait, what's that purple zone over on the far right? What was that? Japan. Whoa. Okay, we got to keep note of that one. And let's take a look at Europe. Europe is color-coded to have historically Western Europe and Eastern Bloc countries differently coded. You can see that. So Western Bloc countries are shades of purple, I guess that is, and the Eastern Bloc are shades of blue. So you get to see who's doing most science today. Let's check this out. Europe completely overruns. Western Europe completely overruns Eastern Europe. This is a map. All this is a map of science that is, research science that is conducted, yet it also tracks economic wealth. Look at this. Japan, Europe, the United States. Three of the wealthiest countries in the world, wealthiest regions of the world. Now wait a minute, what's all this we heard about China? Well, China's there, that's in light green, right? Is that what that is? Yeah, there's China. So you say, well, wait a minute, well, how about China? What's going on? Well, first of all, the great tragedy of this map is that Africa practically disappears. Huge continent, huge land area, it practically disappears. It's one of the great tragedies of the world today. The amount of natural resources and capacity of a continent is completely unrealized. And of course, Africa has some of the poorest nations of the world. It is the skinniest region of this map. So I look at China, I say, well, what's all this we're hearing about China? Here's the problem. This is not the map I should be showing you. This is how much science is conducted. It's not the rate of change of science conducted. If you like calculus, that would be the first derivative of the amount of science that's done. So what we really want to know is how much science was done 10 years ago compared with today. Then you get trend lines, and that's what carries you into the future. That's tomorrow's redistribution of wealth. Let's take a look at how that map looks. Japan's still large. China grew. Western Europe grew even bigger. And where is the United States? I can't even find it. Oh, there it is in the upper left. This battle cry for STEM field support is not idle. It's not just, oh, we just need a few extra people who know science. It has huge consequences for the future of America in this world. You know something? It's not a cliff that we walk over and fall off. No, then it'd be easy because you can see the cliff approaching. It's a very slow trend downward. Like the frog in the slowly in the pot of water that with the temperature rising, it's slow to the point where we hardly even feel it. You got to take a step back, look at maps like that and say, whoa. Here's what happens. You read about the discovery of the Higgs boson, this particle in particle physics. I used to read about discoveries all the time, and they were in American particle accelerators. This was not. This was in Europe, in Western Europe. Japan just discovered a new element. There's going to be a Japanese flag on the right-hand side of that row of American flags from the bottom of that chart. Just discovered it a week ago. And, you know, what country is this anymore? I don't know that I recognize it. This is Louisiana, 2005. Everybody who you ask blames this on Hurricane Katrina. Do you know that Hurricane Katrina, on landfall, reduced to Category 2? It passed through New Orleans, came out the other side, and people were just sort of sweeping up some broken branches from trees. Then the levees broke. Katrina didn't level New Orleans. Faulty engineering leveled New Orleans. This is a point that is not made often enough because it's too easy to just blame Mother Nature. It's too easy to do that. Yes, have the hurricane come through and just tore the city up, not much you can do about that. But to have our man-made levees break, let's wake up. Smell what's going on here. I live in New York City, a steam pipe blew up. This is ripped from recent news headlines. People die when this happens. Steam, you don't know how to move steam from one place to another? Haven't we been doing this for a century now? A bridge collapsed, Interstate 35, Minnesota. That's an interstate. That's not some homespun suspension bridge that the local yokels tried to put up. This is federally funded interstate money and a bridge, and it collapsed. People died. You ever been to Europe or seen pictures of Europe? They have the Roman aqueduct from ancient Rome that's still standing, that was designed to carry water from lakes into the cities. It's still standing. Rome built structures that are still standing 2,000 years later. You know what that really says is that Rome spent too much money on their structures. You know, if your architecture outlasts your civilization, you spend too much money building it, all right? Just a lesson plan there. You want to get fully... What else? LA, trains collided. People think, what, we can't figure out how to move trains? Back in New York, a crane collapsed. So I don't know what's going on. When I grew up, I saw film loops, that's what they called them back then, of other countries where the infrastructure wasn't very good. So you had people being their own workhorses, you know, pulling plows and roads that had been washed out. And we felt a profound sense of privilege to be in a country where none of that was happening. And in these recent years, I see this going on. And so this happens one at a time, and you can always say, oh, this is why that happened, or there was a faulty this. Yeah, of course, but you take a step back and you see a trend line. A trend line that image, that map of the world showed. Here's a hurricane, Hurricane Ike. Devastated Galveston. Galveston's been devastated before, they're no stranger to this. But here's what's curious. We don't yet know how to stop a hurricane. It'd be cool one day if we did. Put some device inside of a hurricane that taps its energy and use that energy to drive the city that the hurricane would otherwise level. You know who thinks that way? STEM people think that way. They say, oh, here's a problem, I'm going to find a way to solve it. If you're not a STEM person, what do? You get in your car and you run away. There's a sign on the highway, you can't read it, it says, hurricane forming in the Gulf. You know, I think they already know that. Is there anything more useful you can tell these folks? Oil spills. There's also, you know, bad skepticism. Here's a book. How to Defend Yourself Against Alien Abduction. I bought this book. I read this book. I heeded its advice. That's why I'm here to talk to you. So somebody wrote this book, got it published, had a marketing person, got it put on shelves. What country is this? And what year is this? 2012. There's another book, How to Survive 2012, Tactics and Survival Places for the Coming Pole Shift. The worry that the world will end. Well, I have a tweet in response to that. I'm going to tweet. Okay? This is my Twitter account. Live tweet. How to get rich. If you fail to convince your friends that the world won't end in 2012, then offer to relieve them of their needless wealth. That's how to get rich. Tweet. Okay, so it just got processed. That is now in the Twitterverse. One of the most extraordinary wastes of time that technology has ever devised. But at least it's an entertaining waste of time. Okay, so back where I was, there we go. I just have a few more slides. I want to make sure we have time for questions. You know, the legal system scares me as well. First time I was ever called for jury duty, I was teaching at Princeton University, teaching astrophysics, and I taught a freshman seminar on the evaluation of evidence, scientific evidence. So I'm in there for jury duty, and you get called, and then the lawyer has this little Q&A part. In law, it's called something in French so that you don't understand what they're doing. You ever know what it's called? Voix de. I just call it Q&A, right? Because that's what it is. The lawyer asks you, where are you from? What's your favorite color? What newspapers do you read? They want to just judge if you might have some bias in the case. so they can remove you from the judgment of the truth. So we're saying all this, and they said, well, it says you're an astrophysicist. I said, yes. They said, where? I said, I teach a class at Princeton. Oh, what do you teach? I said, well, I teach today, this semester, I'm teaching a freshman seminar on scientific evidence and the relative unreliability of eyewitness testimony. 5 minutes after that, I was on the street. Because apparently knowing that eyewitness testimony makes bad evidence counts as a bias in this case, rather than actually understanding what the brain does when it's confronted with data. There's another time. So that was done, all right, out on the street. So 3-4 years go by, I get called again. I said, okay, I'm not going to tell them any class that I teach. I'm going to leave it off the Voix form, all right? So I'm there, and I finally get to like the final 15. There's like 15 of us, 12 in the box and 3 on the side, and they're trying to get the 12 out of those 15. And it's like regular folk served jury. I mean, people from everywhere. There's like the meter maid and the checkout line person and the stock person, you know, the warehouse stock forklift I mean, people from every job in the world, right? And I'm there like the astrophysicist. All right, so the judge reads the case, and he says, well, here's the accused sitting right there, right there. It said in Upper Manhattan, he's accused of a cocaine, accused of being in possession with cocaine. He was in possession of 3,000 milligrams of cocaine, and about these facts there is no dispute. And it goes on and on and on. Is there any questions about these details? And I said, Your Honor, I have a question. Why did you say that the defendant was in possession of 3,000 milligrams? That's just 3 grams. Which is less than the weight of a dime. And the judge says, oh, well, that's just what's written here. So that means he didn't even know what he was reading. I could say, I'll be there in 10 billion nanoseconds, but nobody talks that way. I was back out on the street. So what? I think, because I said, it sounds like, from the way it's written, you're trying to bias the case, making it sound like it's more than it actually is. And all the other people on the panel, they all looked at it, was like, and so I may have contaminated the whole panel. There's a little bit of success. I don't want to leave you totally bummed out here, okay? The American Physical Society, the National Society of Physicists, had one of their annual conventions in Vegas. And then afterwards, this headline came out. I count that as a success. Also, remember the earthquake in Haiti? 250,000 people dead. Haiti's one of the poorest countries in the world, if not the poorest. 250,000 people dead. Magnitude 7 earthquake under Port-au-Prince. But wait a minute. What was the purple country in the far right? Japan. Japan had a magnitude 9 earthquake that made a tsunami that created nuclear reactor failure. 11,000 dead. People focus on the dead. I focus on the fact that Japan is a modern, industrialized, scientifically literate country. So when you have a magnitude 9 earthquake, a tsunami, a nuclear reactor failure, and only 11,000 people dead, you're doing something right. I had a colleague from the area, and I'm communicating with him. It was like 8 days after the tsunami. He's in the town closest to that got hit by the tsunami. 8 days later, he says, yeah, I finally got my internet service back. It was like 8 days. Haiti never had the internet. You know, you can grow up and be, I don't have to convince you guys, you know, most of you are going to go on to STEM fields. We have teachers here who are already in the system trying to promote that fact, but you can be a lot of things in life. You know, this list, engineers, scientists, technologists, lawyers, executives, artists, doctors, comedians. You can be law enforcers, poets. You can be all these things, and I'm not going to tell you, I'm not going to require that you study a STEM field, no. If you don't study a STEM field, I still kind of want you to be scientifically literate, because you're just better off as a citizen. But I'm not going to require that that's what you become. No, I'm not. The difference is, in that list, only 3 of them, engineers, scientists, and technologists. Sorry, I didn't include mathematicians there, but they'd be in those first 3 categories there. They are the only 3 categories of all on the list who actually create tomorrow. The fruits of engineering, science, and technology create financial security for the nation because you invent things that become the foundations of tomorrow's economy. There's the economic growth, geopolitical strength, national security, human longevity, the control of nature. So when the hurricane does come, it serves us rather than we running from it with our supply of toilet paper and water. There's also, of course, the simple thrill of discovery, which attracts me. But you get all the rest of that for free. For free. And, you know, plus there's asteroids out there with our name on it. When the asteroid comes, who are you? Are you, run, bring the toilet paper? Or are you, how can I deflect that? That person is a STEM professional. That person knows math, knows engineering, knows astrophysics, knows geophysics. It's a rock coming from space. That one took out the dinosaurs 65 million years ago. I don't want to be the embarrassment of the galaxy as a culture that actually knew how to deflect an asteroid, knew in advance it was coming, and did nothing about it. That's just embarrassing to go extinct for those reasons. Dinosaurs had an excuse. They didn't have opposable thumbs. They had a peanut brain. It's not their fault. I'm going to leave you with my favorite image of the world. That's my favorite planet, Saturn. Here it is via the Hubble telescope, where it actually sees aurora. That's aurora in the north and south poles of Saturn. Gorgeous. We have a spacecraft around Saturn now, and it took this image. That image is Saturn eclipsing the sun. So Saturn is lit on the other side, and you're seeing a back glow through the rings. So this is the Cassini spacecraft looking towards the center of the solar system. And I want to zoom in on this and show you something quite humbling. Because one thing that being a STEM professional does, in my particular case, an astrophysicist, but all the STEM fields have examples such as this, is you can run around saying, we're Earth, we're big, we're important, we're special, we're this. Or you can carry with you a cosmic perspective that forces you to reconcile your ego with what's actually going on in the universe. So in this image, I zoom in, and that speck is Earth. An incidental few pixels that happen to show up in the photo. This is everyone you've ever known, loved, all political elections, all wars fought, all on those few specks. A point driven home by Carl Sagan in the book Pale Blue Dot. So images like this, I think, force us perhaps to cherish Earth a little more, because it's all we've got. And I know of no better way to honor Earth, to cherish it, and to cherish the universe than to either become a STEM professional, or if not, to certainly embrace it. Because if you don't, nature and the world will surely get the better end of us. And as a minimum, the United States will just fade to insignificance on the world stage. And all of you are actually uniquely positioned to not only reverse that trend, but restore America to what so many of us remembered it to be firsthand, and so many of the rest of us read about. Those days where America essentially led the world in every possible way you could measure it. And it's in your hands to make that happen again. Thank you for your time. So I looked at my time, we got like 10 minutes. And my favorite part is Q&A, because I'm scarred by my Q&A experience in the courthouses. And I want to take that up to the rest of the world. I'm told there are microphones that scatter around. And if there aren't any, I will listen for your question and recite it back again. So are there any questions that people have? About life, the universe, and everything? Oh, we have a microphone right here. Yes, sir.
Yes, I've seen you on many TV shows and Science Channel and so forth, and you've always spoken of how you're worried about our funds going toward NASA, obviously pretty much disintegrating, and you said something about it being half a penny on our taxes, and it's really not that hard to double it to get a penny. And obviously, I would like to see more. How are you trying to champion this cause, and what can we do as citizens to get this back on track so that we are once again leading the world in discovery, not only in this planet, but beyond?
Yeah, thanks for that question. The critics of NASA would say things like, why are we spending money up there and not down here? Because NASA is very visible money when it gets spent. There are spaceships. There's huge engines launching from Earth's surface. And to a person, every single time someone says, why are we spending money up there or down here, I ask them, how much money do you think we're spending? Here's your tax dollar. Cut it where you think NASA has been funded. And they cut 10%, 15%, maybe 5%. And then I tell them, no, it's 1/2 of 1%. And I did the measurement. If you take an actual dollar bill and cut off 1/2 of 1% of it with scissors, you don't even get into the ink of the bill. And so when I say that to them, and I say that brings you all the astronauts and all the centers and the rovers and the Hubble telescope and the space station, they say, oh, I never thought of it that way. And people are always contrasting NASA with social problems that need to be solved. Well, in fact, social problems in America get 10 times more money in an attempt to solve them than what goes to NASA. So you're really saying we'll take this little bit and add it incrementally to this larger pot of money, and you're going to somehow solve all the social problems this way? If you can't solve the social problems of the country with 99.5% of the budget that's left, you're not going to solve those social problems. So that's first. Second, going into space taps all the scientific fields. We're looking for life. I need the biologist. I'm studying the soils of Mars. I need the chemist. We need the astrophysicists, the structural engineers, the mechanical engineers, the aerospace engineers, the geophysicists. Everybody gets tapped on that frontier. When you do that, everybody dreams big again, because there's no bigger canvas upon which to discover than the cosmos. It gets writ large daily in the newspapers. New discovery, new patent to convert lunar soils into materials, new discovery to extract water from the Martian permafrost. All of this would be unfolding daily. And you're a kid, oh wow, I can do that, oh my gosh. You know, when you have such a program that's fully funded and unfolding before your very eyes, you don't need special programs to convince people that STEM fields are interesting. Right now, that's what we're doing. I need some government money so that I can show somebody that STEM is good. Do you realize in the 1960s, you didn't need such programs because we were going to the moon. We were reaching for an unreachable target that all of history said could not be done. And it was happening in that decade. And people were climbing over themselves to get into the physics class, into the math class, because it was writ large. They didn't even have to necessarily want to be an astronaut. They just recognized the value of that enterprise. And in the 1960s, in the middle of the Cold War, a hot war in Vietnam, the Civil Rights Movement, people found time to dream about tomorrow. Few of you are old enough to remember that era. You didn't have to go a week before there was an article in Life magazine, Look magazine, Collier's magazine that talked about the city of tomorrow, the home of tomorrow, transportation of tomorrow. It was all about tomorrow. The New York World's Fair didn't shape the 60s. It was the dreaming of tomorrow of the 60s that shaped the World's Fair. That all ended in the 1970s. We stopped going into space is metaphor. Space is literal and metaphorical frontier for what it is to make tomorrow come. So what can you do? You can try to keep exploration as part of the agenda. Make it a requirement for who you vote into office, a prerequisite. I stopped complaining about politicians because they get reelected every few years. The real force in our country, if we believe in this democracy that so much blood has been spilled to protect, if we believe that, then we know that, in fact, the president and Congress work for us. We don't work for them. And so it becomes our mandate upon their policies. So, another question. So I took 10 minutes to answer that. I'll try to answer more quickly so I get more questions in. Right here, sir.
Dr. Tyson, first of all, I think your tie is awesome.
Oh, well, credit Vincent van Gogh. I mean, had I painted it, I would say, yeah, I did it. But no, this is Starry Night recut to have all the cool parts of the painting appear vertically. I only have one tie that's natively vertical, and I have one with the Saturn V rocket that has the right proportions for a tie. This painting, I don't know if Van Gogh would he be upset or happy. He didn't sell much in his lifetime, so maybe he'd be happy that it got anywhere outside of his studio. But go on, I digress.
Secondly, with regards to our relatively limited knowledge of the universe, do you think that there's a possibility of there being non-carbon-based life in the universe?
Okay, that's an excellent question. And unfortunately, it'll take me the rest of my time to answer that. Is that okay with you guys? Because I'm told you guys have got a strict schedule. But look, I'm going to answer that. The reason why you're asking whether or not you knew it, or whether or not anyone else knew it, the reason why you're asking could there be life based on some other material other than carbon, is that on the periodic table of elements, I guess I could just go there, can't I? I can just go there. So I go that, and then I swivel, and there we go. Awesome. Okay, so if you see, so carbon is number 14, look at column number 14, up at the top, and it's right below it, C, so that's carbon. Everybody in that column, that's a light blue column, has the same configuration of electrons in its outer shell, which means they bond the same way with other elements on the table. So if you can make life that's carbon-based, our entire chemistry is carbon-based, organic chemistry is carbon-based, in principle you can do it based on the element below it, silicon. So there's been a lot of science fiction stories about the possibility of silicon-based life. There's a famous episode of Star Trek, in fact, A silicon is the active ingredient in rocks. So this life form in that Star Trek episode was like a rock. And it moved through rocky mountains the way we move through air. It was a fascinating sort of concept. So, in principle, you could imagine life based on some other. So, the reason why we're based on carbon? There's a reason. Carbon is not only highly abundant in the universe, so it's available for chemical experiments, but not only that, the strength of the bonds of carbon are such that you can actually make more kinds of molecules with carbon than all other kinds of molecules combined from the periodic table. You could take carbon and string it together into a hugely long chain. If you try that with silicon, it would break, you can't sustain, it can make a bond, but it doesn't stick. Carbon is good for this. And what is life? But the most complex expression of chemistry we know. So if you're going to have chemical experiments in early Earth, what's your element of choice? It's going to be carbon because it's abundant, and it's going to be carbon because it's binding in every which way there is. I had Jon Stewart on my radio show, and I asked him, what do you major in college? He said he started majoring in chemistry. And I said, cool. I don't know if you knew that. He later would switch to psychology for interesting reasons. He said, because chemistry, you actually had to know the answer. That was quote unquote. But I said, did you have a favorite element? He said, yes. And he said, carbon. So I said, yes, but what's your reason? He said, oh, because it's the slut of the periodic table. It combines with everything in every way. So I just have to wrap. So it's certainly possible we could find life based on other chemistry. It's just not necessary because there's plenty of carbon to go around in the cosmos. And so our search for life justifiably is anchored on the search for carbon-based life in this cosmos. And my great fear is that aliens, if they're carbon-based and they're more intelligent than us, and they've come to study Earth, you say, well, where are they? I don't think you guys are aliens because you look pretty fleshy and human. And the big fear is that these aliens have already studied Earth and have concluded that there's no sign of intelligent life anywhere. Thank you all again.
Dr. Tyson, on behalf of the VMI, the Corps of Cadets, and the entire Lexington community, we'd like to present you with this gift, and thank you for your presentation.
Thank you.
Wow, is he awesome or what? If you want to feel just a little bit special, I was chatting with him just before we began, and he doesn't just do this for anybody. So you need to feel a little bit special, and if you would join me in thanking Dr. Tyson just one more time, and then I...